Today we're going to talk about composite events. And so we're going to talk about the independent and dependent events, the probability of doing two of them at one time, or the probability of mutually exclusive events. So the probability of two independent events is the probability of A and then the probability of B. So we just do probability of A times the probability of B. Now we do have to be careful with the probability of B. Sometimes it changes depending upon what A is. So you have to be careful with this, but it is still just a multiplication. So Charlie's clothes closet contains 3 blue shirts, 10 white shirts, and 7 striped. What's the probability that when he randomly goes in, he gets a white shirt followed by a striped? So let's take a look at how many total shirts. So first and foremost, there is 3 and 7, so 10, and another 10, so 20 shirts. How many of them are white? So we have 10 out of 20. And then followed by a striped shirt. Now, the 10 out of 20 is there, but notice the next one, it's 7 out of 19. Because he's already taken a white shirt out, there's only 19 left. So it's 7 out of 19. Now we multiply across, so 70 out of 380, and then simplify it to 7 over 38. So what about a plate of cookies? 6 chocolate chip, 4 peanut butter, and 5 sugar. So if you're not looking, randomly a chocolate chip. So there's 15 total. 6 are chocolate chips, so 6 out of 15. And then a sugar. Well, you already ate the chocolate chip, so it's 5 out of 14 there. 30 out of 210 equals 1 out of 7. Look at the difference of these two problems. They're almost identical. Bag contains 4 blue marbles, 3 yellow, and 5 red. What is if one marble is drawn and it is not replaced? So yellow is not replaced and then a blue. So 3 out of 12. There's 3 out of the total of 12. And then it becomes 4 out of 11. Now if we did 2 yellows, it would have been 2 out of 11. But this is 4 because we're doing blue. And multiply it and we get 1/11. Now let's look at it if it is replaced. If it goes back in the bag, it's 3 out of 12, and then blue is 4 out of 12. So notice that number does not change. So be careful with whether or not it is replaced or is not replaced, because we get a very different answer, 1/11 and 1/12. All right, you draw a card from a standard deck of playing cards. What's the probability that that card will be a black 9 or any heart? Now, the issue with this is mutually exclusive. So when we go ahead and we do this, we're going to have to add black 9 plus our hearts. But understand that we are not multiplying this. This is just one probability. We're only pulling one card. We're not doing 2 cards, so this is not a multiplication problem. This is just a single one, so we're just adding those 2 possibilities. Well, black 9, there's 2 of those. And the probability of hearts, there's 13 hearts. So it's 15 out of 52. So we just add those together and then put it over how many total. So be careful with that because we're only drawing one card. So there should only be one fraction. It is not a multiplication. Let's try another one. Drawing again from a deck of cards, what's the probability it will be a club or a red face card? So we're going to do, there are 13 clubs. And how many face cards? We have a king, queen, and jack of each, so 3 of each. So 13 clubs, 3 hearts, and 3 diamonds. Adding those all together, we get 19 out of the 52. Again, only one fraction because it's only one card that we're pulling off. We're not multiplying these all together. And that's what I have for you today.